So the talk is actually just kind of a tour through some of my musical projects the past few years. They'll give just a sampling of a diverse set of things that I'm interested in. The title is kind of just a title, but it does bear some analogy to a kind of a retrospective. I looked at some old music in boxes when we were moving into a new house a few months ago, and I realized, my very first music, as a student, kind of was shaped like that in portrait mode. Very much kind of in a line of musical thinking, I started to scan time horizontally, and this was current in the 60s and 70s. Source magazine, if you look for that venerable publication of the late 60s, is landscape mode, and for good reason. I mean, sometimes it's because of proportional time and being able to see time flow that way. Other times it's to be able to see systems, I think. I'm not going to do too much more with this. It's sort of a hazy differentiation in my work, and maybe not particularly useful, but I think useful when, if I had the right slide at this point, I would show you some kind of digital aspect ratio distortion thing that you can do digitally that you never could do before for forms that are of interest now, and I think those are analogous to what I'm doing in some of my music. Imagine, someone takes a camera and, just clicks pictures in spherical mode, and then this gets stitched together into something that's an inside-out ball. There's a beautiful picture of Karma somebody did recently, and I'm sorry I don't have it, but you look at this sphere hanging in space, and it's not portrait mode, it's not landscape mode, but it's very apt for creation at this point, things like that. So we'll go through a number of projects, and I'm almost going to leave it to your curiosity whether one of these represents portrait mode or landscape mode. But this is a piece which is a structured improvisation, and I'll play it for a while if we get luck with playing. There should be sound coming off the computer at this point. Thanks. Yeah. Is it's a context for improvisation. This was a performance adapted by a trio in Bucharest last year. I hand them a fixed media sound file in 3 movements. They learn it and they play. And so each realization is different, but it has a bit of the shape that I started with back 30 years ago, actually. On a completely different plane, and maybe this is the open form world, this is a sound installation in you can bring it up, in SF MoMA Art Gallery. Jonathan, feel free to ride the levels so it can be heard. It's up to you. Thanks. So this piece is, you know, it ran for 4 months. It's a sort of Stonehenge of loudspeaker columns with IP addresses displayed in 32 bits. And yeah, team effort, you know, many people put into this. But this giant baby pacifier made out of recycled aluminum that the guy's got his hands on is steering ping echo sounds that are translated to music, and he's steering them around these 8 columns. And it's kind of over the top. There's external computers that have been selected. There's ping messages going back and forth to them. A very fast ping is a high pitch. A very low pitch represents a long echo reply from a computer out there. And gallery visitors could select the computers out on the internet that they wanted to listen to. So all that aside, what I'm really interested in building pieces like this is that moment, you know. And when you get that moment, you kind of know you're allowing the auditory system to take over for a bit. Of course, I'm working with fantastic visual artists, and they don't care as much about that moment. But you know, this is my reward. Now we'll actually visit the new concert hall at Standford. We have a fabulous new venue built by Yasu Toyota. It's some of you have been here or there at that vineyard style, and it's the home of our symphony orchestra. There was a celebration of the opening, which was an exhaustive cycle of all 9 Beethoven symphonies and the piano concerti. Now, the conductor thought that doing just the 9th Symphony on the last show was you know, they weren't going to get their money's worth, so they needed a piece by me to flesh it out. So we did a collaborative project where I did the electronic music. We had Do-Hee Moon write the orchestral parts, and just a little sampling of this now. And about a 10-minute piece. The computer music used a technique that I was developing at the time for something I'll get to later in the talk. It's a device called a brain stethoscope, which basically uses frequency modulation, singing voice synthesis. And in this case, I can use it to mimic other things. For example, I can mimic this clip from the 9th Symphony. Okay, so now my system listens to that, tracks it, and pretends that it's vocal formants and resynthesizes it as if it's a singing voice, which goes completely wrong. If you hear the two together now, And that became this kind of extra instrument in the score, which, you know, kids who came to one of the shows, and I overheard, you know, say, is that another woodwind, or, you know, what is that? And that's actually the best compliment. They heard it as an instrument. And for this piece, that made good sense. So now, let's see, that's orchestral music. Now I'm going to take an excursion into a kind of sonification realm, where several of the following things will involve, you know, taking data from outside of music. These are, you know, digital signals that can come from, you know, in my current work, collaborations with, in this case, environmental air quality monitoring systems, but I also work with, in the brain stethoscope, that you'll see a neurologist who's specializes in treating epilepsy. I've done a lot of work actually with geoseismic signals that come from fracking sites, so able to sonify the actual cracking of the earth for better or worse, you know, and this is actually a good device for helping the operators who are like driving all of this force into the ground to know when to back off, you know. So right now they kind of fly blind, and this is a real-time way of listening to the behavior underground. Recent book just came out on synthetic biology collaborations with artists. It's called Synthetic Aesthetics. MIT Press just released it. And we have a chapter on how you can sonify the chapter of these complex molecules that are being manipulated by synthetic biologists in their work, in their engineering work. So this one, we're gonna actually look over the shoulder of a Japanese TV production crew doing a stop in California as part of I think it's a full year series for this TV channel. It'll be in Japanese, where they make stops every week at different locales on the 35th parallel, which is Tokyo. And at some point they come ashore in California, and they needed something thematic for their tour of California. And what better California theme than pollution? So, so you know, thanks guys. That's how we're going to portray our state. I was tapped to put a friendly face on pollution, maybe, I don't know. So, so what I'm going to show is several clips from the final production. Again, you know, Japanese narration, but I think you'll get the idea. The first one is teaching the audience about the source of some of our methane problem in the cattle industry in the Central Valley.
発酵の際に出た水素や二酸化炭素をメタンガスに変えているのです。牛はそれをゲップとして放出しています。
How many times they do in one day or in 1 hour?
So our hero is going to take us on a tour of California. In the proximate area of the 35th North Parallel. First stop is him explaining how our monitoring apparatus works downtown Los Angeles.
音楽にしてもらおうというのです。
はい、街のど真ん中で測ってみましょう。スタート。お、なんかついたよ。
5色に光るランプ。中でも二酸化炭素を示すオレンジと。
So this is a sensor designed by some brilliant engineers in cahoots with some artists, obviously. So you know, that arrangement of LED view meters is you know, not something you would expect out of the engineering department at Berkeley, but it's a great collaboration. And so we're going to use two of those signals, the CO2 and VOC. VOC is volatile organic compounds, you know, perfume, propane, so on.
はい。あ、なんか上がってきたよ。これ息吹きかけると二酸化炭素上がったりする。上がった。えらいことになる。これ俺？ やべえ、余計なことしたら、ね、針振り切ったまま俺の二酸化炭素は強烈だった話ですよ。あ、降りてきた降りてきた。すごいっすね。
こうしたデータがパソコンに入力され曲作りの元となるのです。計測すること1時間、街中の大気汚染データも揃ったようです。ロサンゼルスを離れ
Okay, so he's going to drive north with his crew, sampling along the way. This is a little bit of a, kind of leap of faith production values. We actually collected the data ahead of time, then they did the shoot. This sort of thing happens. Pismo Beach.
ここが第2のポイントです。
Okay, now on to one of the oil patches in the Central Valley.
ロストヒルズ油田は100年ほど前から掘り続けられているカリフォルニアでも有数の油田地帯です。
And just before we go on to how we sonified it, they got pulled over in the oil patch by the sheriff, and this is a great story, so I have to say it. They got pulled over. They had this car full of gear, generators, inverters, and nobody was speaking very good English. And sheriff asked what they were doing, and they said, "Well, we're monitoring air quality." Oh, good. Okay. So yeah, just let them go. So the production crew was amazing, and wanted to do a tag at the end of the show about some of my sort of sonification work that had preceded the tour of California here. So there's an old piece called Oxygen Flute, and they closed their show by going back to some recording of Oxygen Flute, which I'll play for you now. Oxygen Flute is a installation for art galleries, which was a large kind of translucent rubber-walled room that you would go into one or two at a time, filled with bamboo plants. And there's this very high-resolution CO2 monitoring device in there. And the idea in the piece was to be able to make it sort of audible what the transfer of gas between human and plant is. And so that's the aspect of this piece that we were trying to develop, was kind of a new perception of this really precious exchange of gases that goes on, without which we wouldn't be here. And here's how they portrayed it in the
教授は
video.
音楽にしているんです。
ではどんな音楽になったのか聞いていただきましょう。なんか雅楽のような感じでもありますよね。
はい。こう落ち着くような気がします。
So the one word I understand in Japanese is gagaku, and he says, "Ha, sounds like gagaku," and that's another kind of compliment, because I was trying to get this subtle stuff in the synthetic flute sounds. These are physical models of some very old bamboo, no, in this case, bone flutes from China. But aside from the tech, it's again this thing, He does it, she does it. And now I'll let you listen to a little bit of a kind of higher resolution from the piece itself. inside the chamber with the bamboo around you. There were 4 loudspeakers, so we were playing games with spatialization of this group of 4 flutes. And you can see from the bone flutes that were found in China that we've gotten involved with little digital manipulation. So there's 2 flutes here, which I've now sort of stretched in the image to create a couple of, sort of soprano-sized ones and a couple alto-sized ones, but with different tone hole patterns because of the scaling of the 2 sources for this. Stuff that you can do digitally in music synthesis. So the same scaling that goes on in this, in this distorted picture went on in the physical model that's synthesizing the sound that you heard. It's entirely driven by data. Some of the data driving is going in real time. So if you blow on this sensor that would be nested in the bamboo, you'd get an effect on the improvisation or whatever you want to call this algorithmic thing that the computer's generating. You'd also be involved with the speed. You'll be changing the speed with which historical data is actually coming in and innervating some of the flutes too. And because it's a flute, you have a lot of parameters. You have breath pressure, you have tone holes, you even have the ability to simulate key clicks. And you might have heard this kind of snappy sound that's going on. So if there's no breath pressure going in to give you a pitch, you can still hear the pitch because something's snapping the tube, impulsing it. And even though you're not blowing on it, you hear which tone holes are open or closed at that point. So these are experiments that you can do in software, and actually some of them you can only do in software. So the things making the snaps in those flutes are recordings of snapping shrimp from Monterey Bay, California. So we stuck hydrophones out there, got the popping sounds of these little tiny critters that are about this big, and they make a snap, which is not actually a snap. It's a squeezing of water that creates a jet that goes out at a very high velocity, leaving a low pressure area behind it. The low pressure area is a phase change into steam, which collapses. It's cavitation. So the steam collapses and it makes a snap, which is incredibly loud. So makes nice impulses for flutes. It's just hard to do underwater. So if you chart the carbon dioxide measurements that are going on in the bamboo room, over the course of a week, you see where the museum is open, where it's closed for the weekend. You can actually pick up on the presence of light or no light during the closed hours. That's in the box there. And to make this kind of exchange of gases audible, we had to basically try to portray these things that happen at different timescales. Of course, music is ripe with strata of timescales, and we manipulate that all the time in music, from the very shortest timescales to extremely long things. Mapping that onto the people in the exhibit was part of this. Mapping it onto the photosynthesis and so on of the plants was part of it. But one of the challenges was that if you zoom in on a trace of data as a time series, here's what you get. Here's at the top trace is 1 day's worth of CO2 measured in that chamber for 7 hours. And if you zoom in on it, so you're looking at kind of micro time, you see this trace in the second. If you zoom way out, you see this trace that's looking at a month or something like that. And what do you do? It's just bumpy lines, and we're trying to portray something about interaction, but we have no sense of scale and time from those bumps. And I would say that we solved this, but I don't want to go into the details. And we solved it by making people hyperventilate. And I'll tell you about that later if you're interested. So we could make people go in there, play a game. They got hyperventilation going. And they started to realize when they were like in real time or when they were directing very zoomed out types of things. So this is the kind of thing that goes on in design of some of the gallery work, and has been really fascinating. And again, this is very much a team effort, particularly my partner Greg Niemeyer in the art department at UC Berkeley, who's been a part of many of the things I'll show. Next up, a little bit of a network collaboration, real-time network collaboration piece. And this is a little bit like the piece that we opened with, that was the 1983 trio performance. This is a number of saxophones in remote locations from each other on the network. And there's a structure to this, but it's a lot of improvisation and listening. And you have to remember, these people are not in the same room as the audience, except for one of them. And far be it for me to remember where this performance was made. So I only get to play snippets, but this is about a 10-minute piece. This one was actually recorded at the Banff Center. I remember this. The part of the game in this piece is that if I ask the local saxophonist to trigger a sound that's going to be echoed by a saxophonist in Ireland with something like 100 milliseconds of one-way delay, the guy here near me is going to hear a reaction time, right? It's going to be like, I go, in fact, I can do this with somebody in here. Let's see, if I pick on Wisław. Okay, so I'll clap, and Wisław will clap as soon as possible after my clap. You ready? I'm going to fake you out. Okay, right, here we go. Okay, and you'll get better. But you're not looking, right? Remember? No video. So here we go. Right, so you're good. And one of the things that you notice is that that's a very long reaction time. And it's hard to make it less because it's the human reaction time. It's longer than the transit time to Ireland for the audio. So this piece is written to be out of sync. It's written to have this kind of human thing going on. And so the conducting saxophonist makes a splat, and the answering Ireland saxophone has to react as fast as possible when that's the moment in the music. And it totally masks the network delay. You don't know that there is such a thing in this piece. And there's a number of other rules that go into making the performance happen. Okay, so next, just forget all that. Here's some free improvisation with someone I perform a lot with. And this is that sort of open side of my work. Roberto Morales is a performer, composer working in Mexico City. one of the pleasures of working with Roberto is he takes over all of the computer programming, does wonderful 8-channel, sound path stuff, and processes my celletto sounds, and I just get to play. It's awesome. So now take a trip to Newfoundland, where that chef is, and this is from the Sound Symposium, which will be coming around again this summer in Newfoundland, in St. John's. Every Sound Symposium, they ask for a few scores for the ships that are in the harbor. So these are like 5-minute pieces. They get played around 12:30, right in the middle of lunchtime. And you have a captive audience of 200,000 people because it's all the ships in the harbor playing your music, and the poor stevedores that work the night shift don't like this tradition at all. So here's mine. So front and center in there was Canada's largest icebreaker, and that's playing the bass. The score is landscape mode, and you'll notice that I have very synchronized vertical events here. This is in exact proportional time. The way this worked was whoever's in town or in harbor on that moment, they sort of get volunteered to participate. I had 7 ships. We rehearsed with a bunch of volunteers on the dock, and then they went off to all the cabins of the ships, and they were cued into the Coast Guard radio that went, Harbor Symphony, 3, 2, 1, and then the score starts. But it's impossible because there's almost a mile between one ship and another ship. So depending where you're sitting, if they were perfect, you'd get a different, the speed of sound. That's 7 seconds. And so again, this is a piece that's meant for delay, right? So I purposely put vertical, coordination in here so that I could get this kind of smattering of things going on. What I did get resembled nothing like I thought I was going to get. I mean, again, it's like who volunteers and who's in port at the time. But here's a little bit of a better recording of it now. So if I had my way, I would do another one of these knowing what I know now. That's all I can say. But it was a lot of fun and great volunteers for it. If we go back to the Japanese documentary where we're going around with the device, there's actually a live website that does that piece my way rather than the TV producer way. So you go to this site and you'll see a map of all of the locations. And you'll see the data traces that we've got for the records that we used for the following music. And on the site, you can click on one of these locations, and then you'll hear the sonification of the VOCs and the CO2, but with a very different voice than the Hotel California that you heard. Just a little bit of that. So this is one of the more relaxed ones. It's at the beach. Things are changing as the sun's coming up because this was done at dawn. The most relaxed one is in the Mojave Desert, and it's just absolutely fantastic. Because for me, when the data gets really slow and low amplitude, there is this kind of sense that's completely different from downtown LA. That's for sure. And so you can hear it in the music. So another piece which exists online now is polartide.org, which was done for last year's Biennale, and involves both on-site and on-internet collaboration. So right now you could go to the website and you would see an interface that looks like this, which is clickable. And the upper bars are sea level registrations. These are measured in real time at 4 different locations in the world. This was sponsored by the Maldives, an island country which is, in great danger of becoming completely dependent on scuba gear, where things are going now. And Venice itself is somehow threatened, by sea level rise as well. So about once a minute, there's an upload of new data readings from these different places. I don't have it online right now, but if I did, I could click on those white round things, and you would hear a gong tone, which comes from a measurement for any of those locations. Or you could click the ones underneath, which are the stock prices for oil companies that were selected for this. And so this is live. You can look at it, play with it on your devices. When it was in Venice, the piece was here on the facade of the Maldives Pavilion. And you see 8 loudspeakers behind the red banner, which were installed to play the gong sounds. And these were beautiful loudspeakers, and we did physical modeling synthesis of the gongs with 2 things in mind. One was to capture the sort of, I don't know, I call it the natural world, the sea itself, with some kind of gong performance. And the way that was done was kind of analogous to a bell buoy. So if you know bells sitting in buoys, they chime when the waves go by. They rock like this. And they're sort of very complex pendulums. So modeling that with the physical models of the bells and changing the bell pitches depending on the height of the sea at that moment. So that's what you'll hear near these loudspeakers. But to contrast that kind of chaotic motion of the sea, underneath the stock price sonifications did a contrasting thing, which was what I called jingles. So you touch one of those buttons and you get, for the current stock price, you get a pattern of bing bong bong, bing bong bong. It will be the same every time till the stock price changes. So it doesn't have that organic shaping of the other. Then we did this for the Carillon at UC Berkeley, where a performer actually performs the data. The interface and causing notes to be played by the performer. Okay, so my very last thing that I'm going to take you on, and this has been kind of a big medley, I know, and so it's probably at a point where cognitive overload is easy. But I need you to take a quiz now. So we're developing, as I said, a brain stethoscope. This will be a device that you can basically, using dry electrodes, just a couple of electrodes, put them on someone's scalp and on your device be able to hear the brain waves as singing voices, actually. So using this to detect epilepsy for starters. And so I'm going to play you 2 clips, and this is the quiz. I would like you to identify afterwards which one is the seizure. Okay, so now I need your answer. So who thinks number 1 is a seizure? And who thinks number 2 is a seizure? Great. I'll give you the answer after we write the paper. Well, we just wrote the paper. It's number 2. Good. So I think that's it. Tomorrow I'm going to talk about a different topic in the workshop that fortunately is happening while I'm here. And the workshop is about envelopment of various kinds. I'm going to talk about this kind of inner envelopment, like the sounds that we imagine in our head, which are, in my auditory system, almost the most enveloping. I mean, we can kind of turn this inside out. So that'll be my subject tomorrow, and hope some of you can be there. With that, I'd like to thank you for your attention. So.